Hello everyone, welcome back to Z Physics. Today we're going to be solving some practice questions on vectors, units and uncertainties. First off, please excuse my voice. I'm a little bit under the weather, I have a little bit of a cold, so my voice may not be as clear as it normally is. Now with that out of the way, let's start having a go at some multiple choice questions. Okay, so question 1, which of the following is not an SI base unit? So the amp is, the mole is, the volt is not, the kilogram is a base unit, therefore the correct answer is C. Okay. Question 2, which set of quantities are all scalar? So acceleration is a vector, displacement is a vector, velocity is a vector, so it's not going to be this one. Energy, that's a scalar, mass is a scalar, and power, that's just energy over time. So energy is a scalar, time is a scalar, therefore the power is also a scalar, therefore the correct answer has to be B. Question 3, which are the correct base units for work done or energy? Multiple different ways of solving this problem. Pick your favorite formula for energy or for work done. So I'm going to use E is equal to a half mv squared, the formula for kinetic energy. The half has no units. Mass is given in kilograms. Speed is given in ms to the power of -1, then I'm going to square that. So what I'm left with is kg meter squared s to the power of -2, which means that the correct answer is D. Okay, moving on, which of the following sets of measurements of the gravitational field strength G is equal to 9.81 meters per second squared is an example of high accuracy but low precision? So high accuracy means that it's close to the real value, so close to the real value, and low precision means that there's a high spread of results. So for instance, I can see that answer C has a very large spread of results. So one is 10, another one is 10, then it goes to 6.54, 7.57, etc. So that's an example of low precision. The only one that fits the bill is A, because as you can see, the accuracy is quite high, so all of those are very, very close to 9.81, but they all vary. Question 5, we have a 10 kilogram weight is on a 25-degree slope. The component of the weight parallel to the slope is. Okay, well, the component of the weight parallel to the slope is given by the equation, and let's call that component. Let's just call that F. In this case, would be W sine of the angle. So anytime we're looking for the component parallel to the slope, it's the force multiplied by the sine. Now, how do I know that? If this angle here is 25 degrees, well, then let's think about the weight as a combination of two vectors. One is going to be along here, which is going to be the parallel component, and one is going to be the perpendicular component. So you can think of the weight as the sum of these two vectors. If this angle here is 25, well, this here is 90, which means that this here will be 90 minus 25, which is 65, which leaves 25 degrees for this angle right here. So this angle here, maybe I should write this a little bit bigger, is 25 degrees. Okay, well, look at that. The component which is parallel is actually the opposite of this 25-degree angle. So that's why I'm using the weight, which is essentially our hypotenuse, in this triangle over here that I'm sort of highlighting at the moment. The weight is our hypotenuse. This here is the 90-degree. You've got 25-degree. So the component perpendicular, this one here, is W sine of 25, which is going to be 10 multiplied by 9.81 multiplied by sine of 25, which is about 41 newtons. Therefore, the correct answer is B. Okay, question 6. So for this question, you need the formula V is equal to IR. Perfect. Remember that from GCSE. A student determines the resistance R of a filament lamp by measuring V and then the current as well. And we have the values. What is the percentage certainty in the value of R? First off, to determine R, we do V over I. So we're dividing quantities. And anytime we divide quantities, we need to add the percentage uncertainties. So I'll just write this down. We need to add the percentage uncertainties. Okay, well, let's find the percentage uncertainties. Remember, your percentage certainty is equal to your absolute uncertainty divided by the value times 100. So it's going to be 0.20 over 5.0. Then to that, I'm going to add the other percentage uncertainty in I, which is going to be 1 over 40. I'm not bothering to write down the units because they're just going to cancel out from the top and the bottom of the fraction. Then I'm going to multiply them all by 100. Together as a percentage. If I do that, I'm going to get about 6.5%. Therefore, the correct answer is C. Okay, written questions. So let's have a go at some written questions. Draw a line from each unit on the left hand side, the correct equivalent on the right hand side. Okay, well, the joule, we're going to use work is equal to force times distance because work is measured in joules and is equal to force times distance, which is newtons times meters, which is newton meters. So therefore that's got to be true. Power is just energy over time. So that's just energy over time. So that's going to be a joule divided by second, which is joule s to the power of -1. So therefore the watt, which is the unit of power, also one of my favorite puns, is going to be j s to the power of -1. A newton will be kg ms to the power of -2 because F is equal to ma and mass is measured in kg and acceleration is measured in ms to the power of -2. Okay, next one. This question is about estimating the pressure exerted by a person wearing shoes standing on the floor. Okay, estimate the weight of the person in newtons. So weight is equal to mg. So let's say a person weighs about 70 kilograms times 9.81. which is going to give me about 687 newtons. Now, normally there's quite a range within the mark scheme, so if you've chosen 50, for instance, that's fine. It will just give you a smaller value, but as long as you're within that range, you are totally fine. Okay, next one. Estimate the total area of contact in square meters between the shoes of this person and the floor. Okay, well, let's assume that this person has two shoes. I'm going to assume that they're rectangles, and let's just keep it simple. Let's assume that they're 0.1 meters, which is about 10 centimeters. So that's about 10 centimeters. And let's assume that the other dimension is 20 centimeters, which is about 0.2 meters. Like so, and what we need to do is we just need to multiply those two dimensions. So what I'm going to say is that it's equal to 0.1 times 0.2, but there's two of those shoes, so I'm going to multiply the whole thing by 2, put it on a calculator. I'm going to get 0.04 meters squared. Okay, hence estimate the pressure in pascals exerted by the person standing on the floor. Okay, well, pressure is the amount of force per unit area, and we estimated the force to be 687. Then we're going to divide that by the area which we have, which is 0.04, and up to two significant figures. Well, let's just write down a little bit more. This will give us initially 171.175 newtons, but let's just write this up to two significant figures, be about 1.7 times 10 to the 4 pascals. Okay, next question. Complete the table by stating the value or name of each of the remaining three prefixes. Okay, so mega is 10 to the 6, 10 to the power of minus 9. This is nano, and tera is 10 to the power of 12. Now let's use those for some calculations. Okay, so we have a collision between molecules lasts for 100 picoseconds. Write this time in seconds. Now, because pico is 10 to the power of 12, this would mean that this is 100 times 10 to the power of minus 12, and this will be 10 to the power of minus 10 seconds. Chemical bond is approximately 0.515 nanometers long. Write this in meters. Well, this will be equal to 0.15 times 10 to the power of minus 9, which is 1.5 times 10 to the power of minus 10 meters. Diameter of the Earth is approximately 1.2 times 10 to the power of 7. Let's write this in megameters. How exciting. So if we're converting the other way, if we're converting from the standard, which is the meter, to a prefix, we need to divide by that prefix. So this will be equal to 1.2 times 10 to the 7 divided by 10 to the 6, which is equal to 1.2 times 10 to the 1, which is equal to 12 megameters. Okay, part C. A runner travels 5 kilometers in 114 seconds. Find the average speed of the runner and then the percentage uncertainty. Okay, so first off, let's just determine the average speed. So I'm just going to do this first bit over here. So our speed is distance over time, which is 5 kilometers. That's 5 times 10 to the power of 3 divided by 1140. Putting that into a calculator, we're going to get about 4.4 meters per second, which is pretty fast. So that's a very good runner. Okay, well, let's find the percentage uncertainty. So how certain are we of this value? Because we've just divided some quantities, and remember, if we divide quantities, we need to add the percentage uncertainties. What I'm going to do is I'm going to find the percentage uncertainty in the distance, find the percentage uncertainty in the time, and then add them together. So to find the percentage uncertainty in the distance, I'm going to do 0.1 over 5.0 plus the percentage uncertainty in the time, which is 1 over 1140. Multiply them all by 100, and let's put that into a calculator, which is going to give me about 2.1%. So we are certain of the speed of our runner to be 4.4 meters per second, plus or minus 2.1%. Okay, now let's solve some vectors questions. So question 3, oops, what's happened here? Let's go back to the vectors questions. There we go. So figure 5.1 shows a 20 Newton force acting at an angle of 38 degrees to the horizontal. Determine the horizontal and the vertical components of this force. Okay, so this will be one of the components. We'll also have a vertical component. The horizontal component will be given, so I'm going to write x for the horizontal one just here. This will just be 20 because that's the adjacent component. It will be multiplied by cos of 38, which is about 15.76 newtons, and the y component will be 20 times sine of 38. So let's just put that into a calculator. So 20 times sine of 38 is going to give us about 12.3 newtons. Now up to two significant figures, the horizontal component will be 16 newtons and the y component will be 12. Okay, next one, define a vector quantity and give one example. So first off, for defining the vector quantity, it's a quantity with a direction and a magnitude. So it has both of them. Any valid example here will do. For instance, I'm going to write a few. We have velocity, force, acceleration, etc. Okay, next one, figure 3.1 shows a force at an angle of 30 degrees to the horizontal. We're given the horizontal component is 7, so let's just draw that. So this here will be 7.0 newtons. Calculate the magnitude of the force F. Okay, well, if the horizontal component is 7 newtons, we can just simply use the fact, or just use some simple trigonometry, and just use the fact that the cosine of 30 is equal to our adjacent divided by our hypotenuse. Now our adjacent is 7.0, our hypotenuse is f, so this means that cosine of 30 is 7.0 over the force f. So we can just rearrange for the force, which is going to be 7.0 over cosine of 30, which is going to give us 8.1 newtons. Okay, so for the next one, figure 1.1 shows two sets of quantity listed as scalars and vectors. State that one quantity has been incorrectly listed as a scalar. Well, as soon as we see that, as soon as we read the first one, we know that acceleration is a vector. You can have acceleration in one direction, then the other direction. That's how you speed up and slow down. So we can just write that down, acceleration. Two quantities that have been incorrectly listed as vectors. Well, displacement is a vector, energy is not a vector, and power is not a vector. Either velocity is a vector, weight is just a force, so it's a vector. So it's going to be energy and power. Okay, part B. For this part, remember the resultant force F is equal to ma, where m is the mass and a is the acceleration. Okay, we have an object that's acting, we have a couple of forces acting on them. Calculate the magnitude of the acceleration of the object. Well, the acceleration, because F is equal to ma, where F is the net, the resultant force, the acceleration will be equal to the resultant force divided by the mass. So we have two forces acting, we don't know what the resultant force is, so we need to add those two vectors. The first thing that I need to do to add vectors together is just to rearrange them tip to tail. So this one here is 7 newtons acting this way, and we also have a 5 Newton vector acting this way. The angle to the horizontal is 40 degrees. Okay, well, probably the easiest way of doing this is by using the cosine theorem that will allow us to find the resultant. So let's say that this here is our resultant. Let's call that f, and the cosine theorem kind of works like the Pythagoras theorem for non-perpendicular vectors. So we can say that f squared is going to equal to 5.0 squared plus 7.0 squared, take away 2 times 5 times 7 times the cosine of the angle between them, which is 40, which means that f is going to be the square root of that expression. So it's like 5 plus 7, take away 2 times 5 times the cosine of 40. And if we put that into a calculator, we are going to get 4.5 newtons. Okay, well, the acceleration then will be equal to 4.5 divided by the mass, which is 320 grams, so that's 0.320, which if we put that into a calculator, we're going to get about 14 newtons. Now, just before I move on, there's probably a few of you guys that might do this via vector resolution. That is totally fine. So I just want to show you a different way of tackling this question. So I'm just going to get rid of this solution just temporarily, so we can solve this question a completely different way. I think it's actually probably more time consuming, but we're going to get exactly the same answer. Okay, well, the 5 Newton vector is going to have two components, and we can find them really easily. So the 5 Newton vector has an x component, which is going to be, so that's 5 cosine of 40. So the resultant x component is going to be this guy here, 5.0 cosine of 40. However, look at that, they're now in the other direction, so we're going to need to take them away from one another. So that's going to be 7 minus 5.0 cosine of 40, which is about 3.17 newtons. Now in the y direction, we don't really have anything else other than the y component of this 5 Newton vector, and that is just equal to 5.0 sine of 40, like so. So let's just calculate that. 5.0 times the sine of 40, which is about 3.21. Now I can calculate my resultant using Pythagoras now, because essentially I have two vectors. One is going up at 3.17, the other one is going the other way at always the other way, isn't it? One is going up at 3.21, then one is going to the right at 3.17. So I could just use Pythagoras and say that the resultant force will be equal to the square root of 3.21 squared plus 3.17 squared, which up to two significant figures is equal to 4.5 newtons. And this is a second perfectly valid way of getting the right answer. Okay, find the direction of the resultant force. State your answer as degrees from the horizontal. Two different ways. You can either use the sine theorem, or if you've done it the first method that we first did, using the cosine theorem. Or if you have the individual components, you could just use the tangent of them. So let's say that I know that the x and y components of 3.17 and 3.21, so the angle to the horizontal is going to be this angle right here, where, by the way, 3.21 is this component here, 3.17 is this one. Okay, so I can just use that tan of theta is equal to 3.21 over 3.17. Theta is equal to tan to the power of minus 1, 3.121 over 3.17. Let's put that into a calculator. So we're going to use the inverse tangent of 3.21 over 3.17, and that's about 45 degrees. Now your answer may vary a little bit depending on some of the rounding, or if you've used higher or lower precision, because all of these trigonometric functions, they change really rapidly. For instance, I redid it using the sine theorem, this answer, and I got about 46 degrees, which is also, absolutely fine. Okay folks, well, hopefully those questions make sense. Any questions, let me know, and I'll see you in the next video.